Today, I'm going to talk about our paper recently accepted by monthly notice. The title of this paper is Luminosity-duration relations and luminosity functions of repeating and non-repeating fast radio bursts. I'm Hashimoto from National Tsinghua University in Taiwan. This paper is done in collaboration with these people from the same university. Okay, so this is the outline of my talk today. So I will start with introduction about what is the fast radio burst, and then I will summarize the main result in our paper, and then let me conclude in the end. Okay, let's move on the introduction part. So what is fast radio burst? So fast radio burst is new population of astronomical transients that were recently found. So actually, the fast radio burst is a kind of radio pulse with very short time scale of milliseconds. So now many astronomers are excited in fast radio bursts because this radio burst is coming from the extra galaxies. Actually, during last 2 years, there are more than 10 nature papers were published. Now problem here is that the origin of the fast radio burst is still unknown. We really don't know what is the FRBs. So understanding this origin of FRBs, fast radio burst, is one of the most important tasks in astronomy now. So observationally, so there are two different types of fast radio burst FRBs. One is repeating FRBs, another is non-repeating FRBs. So for repeating FRBs, we will see a multi-radio burst from the single progenitors. For non-repeating FRBs, we will see only single burst from single progenitor. So, but it might be possible that we are just looking at only the part of the repeating FRBs, and then we will recognize it as non-repeating FRBs because of the observational limitations. So this might happen. So in this sense, so the origins of repeating FRBs and non-repeating FRBs may be same, but may be different. But we are really not sure about this. So understanding this point is a key to reveal the origin of fast radio burst. So therefore, the new physical parameters to characterize fast radio burst have been awaited for a long time. Then in our paper, we for the first time found that FRBs, fast radio burst, can be divided into two different types in this parameter space. So this is in y-axis, the burst duration. This is an indicator of how long is the duration of this pulse. As a function of luminosity, this is indicator of brightness of FRBs. So in this parameter space, we found that the repeating FRBs and non-repeating FRBs are located at very different places. So actually, repeating FRBs shows a longer duration with much fainter luminosities. In addition to these parameters, we also investigated the luminosity functions of fast radio burst. So here, luminosity function is the number density of fast radio bursts as a function of their luminosity. So in terms of this luminosity function, we also found that the non-repeating FRBs of luminosity function of repeating FRBs is actually very different from the luminosity function of non-repeating FRBs. So these results indicate actually the origin of repeating FRBs is likely different from the origin of non-repeating FRBs because these two are different in terms of luminosities, durations, and luminosity functions. So this is the main conclusion in our paper. In addition to this, this luminosity function also provides us the important implication on the origin, possible origin of fast radio burst. So this is the luminosity function again. So we found that the luminosity function of faint FRBs are actually consistent with number density of possible candidates of progenitors of white dwarfs and magnetars, type I supernova, and soft gamma ray repeaters. This may indicate that faint populations of fast radio bursts may be originated in any of these possible candidates or progenitors. Okay, that's it. Thank you very much.